Alright folks, we're back with another algorithm video. Problem for this video is given a string and a number of rows, print the letters in a zigzag fashion. So if we look here, we have the string. This is a hard problem and the rows given to us is 4. So we print the string like this. It goes down, then up and to the right, and keeps doing that until it's out of characters. Alright, so the pseudocode for the algorithm I came up with is step 1, figure out how many horizontal indices are needed. Step 2 is to figure out whether that position we're at has a character or not, and if it does need a character, we need to figure out which index from the string we're going to print there. And if it doesn't need a character, we just print a space. So in this example, we're going through the columns first and then the rows until we reach this bottom right position. And we first need to check if there's a character there, and then if there is supposed to be a character there, we go to the string, and using a formula, we figure out which index from the string we print. Alright, so we need 3 formulas. We just discussed those. So we're going to use these variables to come up with formulas, which I've already done. We'll just look at them. So we use the I as the vertical index, we use the J as the horizontal index for the 2D matrix. Then we use N as the number of rows. You don't have to do this, I just do because that's how the formulas are written out. And then the size is the length of the string. So if we look here at this first formula to figure out the length of the 2D matrix, we can split it into 3 parts really. So the easiest way to explain this is to look at like the final result and explain it through that. So look here, the green part here is dividing up the matrix into chunks, and by chunks I mean we have a full column and then it leads up to a new column. So we take this as one chunk. So this green part figures out how many chunks we have. So in this example we have one chunk here, and then it multiplies by the width of each chunk, which in this example would be 3, because 1, 2, 3. And it turns out that the width of each chunk is always just 1 minus the rows that we're passing. So the rows are 1, 2, 3, 4. 4 minus 1 is 3, the width is 3. So this gets us 1 times 3, which is 3, and then we add 1 because there will always be one extra column we need to add on. So that just accounts for the last column. So we're at 4 now, and then this red part accounts for any outliers. And by outliers, I mean if there's any numbers that are after the last column and don't lead to a new column. So this would just be one outlier. We would add 1, so we're at 5 now, and you can see 1, 2, 3, 4, 5. So that's what this formula does. Yeah, let's move on to the second formula. So this is a conditional statement that handles multiple cases. Basically what this is doing, it's using a bunch of arithmetic to see where in the 2D matrix we are, and it does a little extra arithmetic like this. It will add the j plus I and divide by the rows minus 1 to see if that equals 0. And it's actually pretty neat how this works. So we'll take an example. There's supposed to be a number at 2 and 1. So 2 is the j, I is the 1, so 2 plus 1 is 3. 3 is divisible by n minus 1, which is 3, perfectly. And then it works for like every one of these positions. So 1 plus 2 is 3. Let's see, 4 plus 2 is 6. 6 is perfectly divisible by 3. Alright, so let's look at the first section of this. So there's really 3 cases. This first case handles if we're in one of the columns and if that column is to the left of the last column, because in some situations the last column, like over here, it won't have all of the numbers the program thinks it should have. It might have only like 2 in this scenario, where all the columns to the left of the last column have all their numbers. So that's what the green case is handling. The yellow case, let's see, the yellow case is handling if we're in the last column and it doesn't have all the numbers. It basically handles not printing these last 2 numbers here. Like the program might think that there should be 2 numbers here based on the green condition and the blue condition, but the yellow condition makes sure that we only print these top 2 numbers. Alright, and then the blue condition is checking to see if, basically we're looking at these middle numbers here, the ones in between, the ones in between the columns, like 4 and 5, and then 4 and 5, 10 and 11, and it's checking to see if, first off, the j plus I is divisible perfectly by that n minus 1, and if it's to the left of the last column or it's above this line, this I equals 1, because we don't have numbers here. Alright, so then we'll look at our last formula, which is quite intuitive, and it's actually quite simple for what it does. It figures out which index from the string to print. So here we can see it's j plus I divided by the n minus 1 times 2 times n minus 1 minus the row. So if we take a look here, if we're at 2, 1, and there's 4 rows, we are supposed to get 5 here. So 2 plus 1 divided by 3 is 1. Then we multiply it by 2 times 3, so 6 times 1 is 6. And then we subtract the row number. 6 minus 1 is 5, and it works. And it turns out that that works for every position, which is kind of cool. Alright, so that's the theory behind this problem. Let's go ahead and jump into the code. Alright, so here I'm in the code. I have IOStream and string for the libraries, std for our namespace. We have two helper functions. We have a getString and getRows. That's it does what you think it would do. It gets the string from the user and the rows from the user. And then we check if the rows here in our driver is equal to 1. If it is, then we just print out the string, because we don't have to do any zigzag thing, because there's only one row. And then if it's greater than 1, we will call the zigzag function, passing in the string and rows. Alright, so here in the zigzag we set our variables we talked about. And then we set our horizontal iterations using that first formula. I'll show you here. Nope. We use this formula to set that. And then we can use that in our nested loops here. So we are looping through the rows in this vertical iterations loop, and then we're looping through the columns in this second loop. Alright, and then here in this highlighted section we're checking to see if the position needs a character or not, and we're using that formula we discussed. I'll show you. We're using the second one. It's a condition that uses formulas. And then if it does, we use the third formula, and I kind of split it up into 2 sections, but it's still the same thing. And then we call that index from the string and print it. And if it doesn't need a character, then we just print a space, and after each row we go through, we end the line. So that's what this program does. Let's go ahead and run it. Alright, here I am in the folder with the executable. We'll run it, and we'll just input a bunch of stuff, random stuff, and we'll give it a row number. Notice how the length is 20, so we want to do something under 20, so 5. And it prints it like that in between the lines, so that's good. Just for clarity's sake, we'll run this one more time, and we'll put in more random stuff, and we'll give it like 10. So you can see it prints out 10 rows in a zigzag form. So that's what this program does. It was a pretty hard problem. Try it on your own. Make sure to reference the source code on the Git repository if you get stuck. Thanks for watching. Catch you later.